Okay, hi everyone. I want to start off talking about Descartes and these first three of the six meditations, the only meditations that we're going to read together. But before we get to Descartes, I actually want to go through a bit of an exercise. This is one that I normally do in the classroom when I start talking about Descartes at the start of the term. And so if you want to pull this up, this is on the Dropbox folder uh, under this file. It's called lsatscan1. So if you pull that up, it looks like this. And what I want you to do is to look at this problem. It's a logic game, it's a logic problem. And I just want you to try it. So here's what it says. It says 6 runners, N, O, P, Q, R, and S, run in 2 separate 100-meter heats, and there's no ties in either heat. And then what this problem does is it gives you these rules, these 4 different rules. And you can consider those to be the kind of global rules which apply to all 5 of these problems that you see in front of you. Now, the answers to each of the problems might be independent of each other, they might be different, but these 4 rules at the top apply to all the problems. And so what I want you to do is just pause the video, try these problems for a couple minutes, maybe 10 minutes. After 10 minutes, if you finish all of them, great. If not, and you want to keep going, that's fine. I figure after 10 minutes, people either decide whether they want to keep going and try to finish it, or they kind of give up because they're tired of it. Either way, that's fine. After you try it on your own, I want you to restart the video, and I'm going to go over how to solve this problem. After I go over how to solve it, I'm going to say why we're bothering with this short exercise, because it has to do with a couple of modes of reasoning that I want to talk about very briefly. And then this will lead right into our discussion of Descartes. So go ahead and try the problem. Okay, so assuming that you tried it, I want to go through one way of explaining how to solve this problem. And to do that, this is going to be unusual for what we do, by the way, but I do want to try this. So suppose we just make a table, and it looks like this. And we draw it where there are 6 spots. And 2 heats. So call this heat 1, call this heat 2. Now in the problem, we're given these global rules, and it says the same runner who finishes second in heat 1 finishes 5th in heat 2. So we can make that a rule. And I'm just going to start it like this. So whoever finishes here has to finish here and vice versa. They're always going to be the same. There's also a rule which says P always finishes third in both heats. Q is last in heat number 1. And then it says that N finishes 4th or lower in both heats. And so we want to figure out how to solve this for each problem. A little, okay. And so I'm going to fill in this table for some of them, except for the first one. I think we can just talk it out. So if you look at the first problem, it says, which one of the following could possibly be the finishing order of heat 1? Well, it seems as though if you do something like a process of elimination, answer A and answer E both suffer from the same problem. That problem is that N finishes second in both of those answers. But we know, based on this rule, that N always has to finish 4th or lower. So it doesn't look like A or E could be the possible answer. The other thing is that with B and D, O finishes in the last spot instead of Q. D also suffers from the problem that N finishes 3rd instead of 4th or lower. So it looks like the only possible answer for 1 is C. It could be the case that in heat 1 it goes O, S, P, N, R, Q. That's perfectly possible. So it looks like number 1 is C. Let's do this. Okay, I hope that one makes sense. We might start filling in things with number 2. So instead of flipping back and forth, I'm going to read off of the sheet that I have. So with 2, it says if Q finishes 4th in heat 2, in which place must N finish in that heat? And so the way to reason about this, one way, is that if you look at the problem, it seems as though if N has to finish 4th or lower in both heats, there's no possible way it could finish in the 5th position in heat 2, because if it did, then it would also have to be in the 2nd position in heat 1, and that would violate this idea that N has to finish 4th or lower in both heats. And so if Q finishes 4th in heat 2, N would have to finish 6th. And that actually gives us a rule which, in essence, is going to apply to all the problems. N can never finish 5th in heat 2 because of that star rule that we have, that first rule. And so if you look at the answer sheet, in which place must N finish in that heat, it would have to be 6th, which is E. Okay, so that's the second one. Now, if you look at 3, let's work through this. So R and S, if R and S finish 5th and 6th respectively in heat number 2, so it looks like this. We don't even have to read the rest of the problem yet. We already know a couple of things. First, we know that N only has one spot left in heat 2, that's here. And we also know that R has to finish 2nd in heat 1 because of the star rule. So it says if R and S finish 5th and 6th respectively in heat 2, and if O finishes before Q in both heats. Well, what that means is we're not really sure where O is over here because it could be before Q in any one of these positions. But with only 2 spots left in heat 2, that means that O has to finish here and Q has to finish here because there's only 2 spots left. So with those conditions, all of the following must be true. Has to be true except for what? And so it says A, well, O finishes 1st in heat 1. Well, that doesn't seem to have to be true. It seems like a possibility. So it seems like that's plausibly the answer. But let's look at the others real fast. B says O finishes 1st in heat 2. Yeah, that has to be the case. C says R finishes 2nd in heat 1. Yep. Q finishes 2nd in heat 2. Yes. And N finishes 4th in heat 2. Yeah, that had to be the case too. So our thought at the start that O finishes 1st in heat 1, that doesn't have to be the case. So it looks like it's going to be A. Okay, so I hope that makes sense. If it turns out that one of my explanations doesn't quite work for you, and you want to blog a comment or a question about this, please do so. And I will go over it again. Question 4 is a little quicker. If the same runner finishes 6th in both heats, well, what that means is we already have Q over here, so it would have to be the same over here. Which runner can possibly finish 4th in both heats? And so here, it's really that star rule again, which matters. Given that this spot is taken by Q, N can't go here. The only runner that could possibly finish 4th in both is N, because N has to go in this position. And so the answer there, N, is A. Answer A. Okay, one more, and then I will say why we're bothering with this. So if you look at number 5, it says if O finishes before P in both heats. So just take that small part. If O finishes before P in both heats, what that means is it could finish here or here. And then at first we would say to ourselves, it could finish here or here. But in fact, with heat 1, it has to finish in the first spot. It has to finish there because, again, by that star rule, if we were to put it here, it would have to go here in heat 2, position number 5. But that would mean it's after P and not before it. So that's the only possible spot for O over there. We don't know where it is over here. So let's just put some question marks next to it. So if O finishes before P in both heats, and if R finishes last in heat 2, how many different finishing orders are possible for heat number 1? So given those conditions, we want to figure out what else we might know. Well, here's something. We know that this spot is filled. N can't go here, so again, N would have to be here. And then there's just one more step, which is really the crucial step to figure out this problem. Well, if we start asking what else can go in these positions, if we look at heat 2, for instance, we might say in this spot, well, could it be O in this position? Well, no, it couldn't be O because O has to be in 1 or 2, so not that one. Could it be Q in this position? And again, the answer has to be no. And here's why. If Q were here, it would have to be second in heat 1. But Q is already placed in heat number 1. Q is placed in the 6th position. So in fact, Q can never be in that 2nd position and then the 5th. So it can't be Q either. And the only thing that leaves is S, because P, N, and R are already placed. And so we don't know where Q is. It's one of these two spots. But we know that S is here. And if we know S is there, S also has to be there. But we're not forced to say anything else about this problem. And so what we have is either the case where the finishing order for heat 1 is OSP NRQ or OSP RNQ. And with both of those combinations, we have two possible finishing orders. And in this problem, that answer is B. So, again, I hope that those explanations make sense if you try to work through it. But the question is, why did I bother? Why did we start with this little intellectual exercise? And it's because I want to note something about this piece of reasoning. And so, in order to do that, let me just write down something, and then I'm going to start a new video in just a moment. What we can say is that the kind of reasoning or the process that we just went through, this thought process, is what's known as, and I think you've seen it before, it's known as deductive reasoning. And that's an important kind of reasoning. It's going to connect up directly with what René Descartes aspires to do in these meditations. And so in just a moment, I'm going to distinguish between deductive reasoning and inductive reasoning, in case you've heard of these terms before. I'll give you a quick example of inductive in a moment. Before that, though, you should know I took this, so it's called LSAT Scan 1. LSAT stands for the Law School Admissions Test. And so these logic games are actually 1/3 of that law school admissions test in order to achieve a score and just to try to get into law school. Because it really is a one kind of reasoning that people have to try to master. If, for example, they're going to go into a legal career, but also it's a kind of reasoning which a lot of us should aspire to master, or at least get better at if we can do so. And so even if you didn't get the problem completely correct, that's perfectly fine. But I'll say in just 1 second why this kind of reasoning matters and why it's a little bit different from inductive reasoning.